So of course we can use these properties, the properties of logs, in the reverse order to condense logarithms. And we actually use this method quite a bit when we get into solving logarithmic equations. So here's a real simple example, right? So if I have this expression, log of 3x minus log of 4y, remember that's base 10 since there's no base written there, I can condense that down to a single logarithm of 3x over 4y. When we start solving equations with logs, it's going to be important that we only have a single logarithm to work with. And so if we need to condense them down, then this is how it condense them down from 2 logs to 1. This is how it works. So we use this particular approach quite a bit. Here's another one. 2 times log base 2 of 5 plus log base 2 of 9 minus log base 2 of 75. And we want to condense that down to a single log. So log base 2 of 5 squared, so this 2 jumps up and becomes an exponent, plus log base 2 of 9 minus log base 2 of 75. Now it's important to remember that anytime you're expanding or condensing, all of the logs have to be the same base. So this is going to be log base 2 of 5 squared is 25 times 9 over 75 thanks to the subtraction. And of course, I don't know, that's going to be something if we simplify it. It'll be basically 3. 3. Log base 2 of 3. All right. So you can see that we've simplified it down. We've condensed multiple logs into a single log. All right, so a lot of times, though, when we calculate logs, so let's switch a slightly different topic. We've been doing stuff like this. Log base 4 of 64. Now, that particular log we can do in our head because remember what we do is we say 4 raised to what power is 64? And the answer is 4. Or, so, excuse me, 3. Right? We can calculate those. But more often than not, we're going to run into logs that we can't have nice, neat powers. 4 raised to what power 64? Well, it's going to be somewhere between 2 and 3 because 4 squared is 16. That's too small. 4 cubed is 64. That's too big. So how do we find actually what log base 4 of 60 is? Well, the answer is we use our calculator. But the first problem we have is our calculator only does 2 logs. Your calculator does not have probably a log base 4 button. Instead, you have just a log button, and that's log base 10. Okay? Or you might have, or you will also have an L in button. And that's log base E, our natural base. So it's important to remember that when we're dealing with those 2 particular logs, we use these shorthand notation. And so your calculator can do either of those logs, but it can't do log base 4. Well, it turns out that we can change any base to any other base. Here's the change of base formula. So if I have log, let's see, log base b, some base b of x, I can change it to another, I can change it to base a. It's just going to be log base a of x divided by log base a of b, right? And now all of a sudden I'm working in log base a. So log base 4 of 60, if I wanted to change the base there to log base 10, so my calculator would do it, it would be log of 60 divided by log of 4. And my calculator can do both of those. I would just divide them, and I would get my answer, right? So that lets me change logs from one base to another base. Just throw that in my calculator here, and there it is. It's about 2.953. Now that's going to be an irrational number. That's why I'm using the approximation because I've rounded to 3 decimal places. All right. So just remember that. You can use your calculator to find any log of any base. you just use this change of base formula.